doing Codeforces Round 789, and yeah, let's go. I've created a basic template. Let's copy it here also. I don't know what that is. Has a sequence A of length n. For each operation, she selects two numbers. If AI is equals to AJ, change one of them to 0. Both of them. Okay. Minimum number of operations to change all numbers in the sequence to 0. It can be proved that the answer always exists. Let's copy the test case. In the first test case, one of the possible ways to change all numbers. Okay. If AI, then minimum of AI and J. What are the constraints? Constraints are n is 100 up to 100 and t is 1000 and AI is up to 100. Weird. So if n is up to 100, can we do a O of n square approach? But let's say, what is the approach? In the first test case, first operation a1 is less than a2, so we make a1 to be equal to a2, that is 1, and now they are same, so now we can reduce one of them to 0, and so this becomes 0 1 3, and in the third operation, okay, we can make 1 0 and then we can just go on with it, right? So what we can do is we can take a map int m and m of a of I plus plus, and if m of a of I is greater than 0, that means we have found one element that is same, right? So we can say that int and same is equals to a of I, and what we can do is, in the first step we make a 0, and in all the other steps we make all numbers 0 that are non-zero. So we also need to keep a count of 0, I guess. Count 0 is equals to 0, and if a of I is equal to 0, count of 0 plus plus, and what we can do is so if count of 0 is greater than 0, then that means we already have a 0, and we just need to do n minus 1 operations, or what we call it, n minus count of 0 operations, right, to compare that. So I guess this is the answer for this case. Else if count of 0 is not 0 but we have same is not equals to -1, let's say. So same, we can keep it -1. So if same is then not equal to -1, that means we found a number that had the same value. So what we can do is we can do one operation to change that to 0, and then we can do n minus 1 operations to make every other element 0. So in total there will be n operations, I guess, and else we just have to say n plus 1, because uh, then we'll make one pair that is equal, and that would require us n plus 1 approaches, I guess. I don't know why did it fail. Please, come on, come on. You should never trust online IDEs. Yes. Okay, there is no match. Huh. No match for call. Oh, sorry. This is not a function. This should be square brackets. 432 is correct. So I'm not gonna check it again. I'm just gonna submit it. Oh no. Even the first question has 2 parts, and that sucks. Retest passed. Okay, let's see the next question. And now I don't know which online ID to use. This is the easy version. Only difference is that the harder version asks additionally for a minimum number of subsegments. What does that mean? Okay. Has a binary string s of length n. Okay. N is even. So let's write this down. N is even. Let's pull out our standings. I just want to see. Okay, we are currently 1657. Great. Now this guy divides S into minimum number of contiguous subsegments. What does that mean? Minimum number of contiguous subsegments. And for each subsegment, all bits in each subsegment are the same. And after that, S is considered good if the lengths of all subsegments are even. For example, if S is this, it will be divided into 1, 1, 0, 0, 1, 1, 1. Their lengths are 2, 2, and 4, which are all even, so this is good. Another example, this divided into this, and the lengths are this. Obviously, this is not good. And I don't know what that means. Minimum number of. Okay. Wants to make S good by changing the values of some positions in S. Specifically, she can perform the operation any number of times. Change the value of Si to 0 or 1. Can you tell her the minimum number of operations to make S good? Nice question. So let's take the input. Oh, I forgot I had a template, but never mind. We have n, and then second line contains a binary string s and of length n, only of zeros and ones. And I don't know why they always give this sum of n over all test cases. That is interesting actually. Can we do of n square then? Okay. For each test case, print a single line with one integer, the minimum number of operations to make S good. Let's take the first test case. One of the ways is change S3, S6 and S7. Are we starting from 1? Okay, S3, okay, S3, S6, 4, 5, 6 and S7. This becomes this, I can divide into this, which means to make the other ways. Okay. Now what? I just like to write a for loop. Okay, how will we do this? Can make a vector and s or counts, right? And what we can do is if s of I is not equals s of I minus 1 or x1, then we just ct dot push back the counter now. So what this will do is basically go on like this. So if 1 is same as the next element, it will add 1 and we can keep this as 1. So these are same, so this will turn to 2 and then these are same, so 3, and when these go different then this will push it and change C to 1 to 0 or 1, and then we can go ahead, and at last also we need to push back whatever the value is inside C. And now the point is that if all values of CT1 are already even, so we can also check it here. If CT1 mod 2 is equals, let's say odd, then we turn flag to 1 and let's take a flag to 0 and we can check if we can also check here, right? So if flag is equals 1, then we are in deep trouble, and if flag is 0, we can just display 0 because we don't need any operations. And now what? So looking at the first test case, they might be misguiding us, so we can try our own way to do it. So if we make this to be 1, okay, so the problem is that this is odd and this is odd, and if we make this 0, now this will become odd, so now we make this 1 and this one, so that would be 4 operations, but they have done it in 3 operations. That's cool. So instead of Can we do it right here? Can we guys just say that s of I plus 1 is equals to basically s of I, and then we go. Can we do this? And if we do this, we are gonna change the parity of the next one and the next one and the next one. Like the question is, okay, so let's say if I do not make this to be 0, I instead make this to be 1. So 1 1 4 once, and then I go get a 0, and I want this to be also 0. Then if I'm going by that algorithm, uh, that's a tough question. Greedy approach might work. I'm just confused that if greedy will work or not. Um, let's see the harder version of this. Meanwhile, she also wants to know the minimum number of subsegments that is can be divided into among all solutions with the minimum number of operations. Oh, oh. So minimum number of subsegments. So she wants that instead of like trying to create more subsegments, we shall reduce the subsegments. Like since we removed this one subsegment, we made this to be even and like this to be even. 6 is even, right? I don't know. Let's see the last test case. So in the last test case, what we can do is we have this odd. We can make this 1, this 0, and this 1. How do we know that it is the minimum? Like if we go by this, we can make this 1. What? We can make this 1 and this 0. This we can remove. Okay. So 1, then a 0 here, and a 1 here. Okay, so the greedy approach is working, or am I an idiot? So what I'm saying is that if I do this operation and and just take an int answer is equals to 0, and I just do answer plus plus, and instead of doing this I do this. Okay, so I'm doing an answer plus plus, I'm changing it to 0, and like the same character, and then I should not break, right? So I should not do this, right? Hence, so if it is same, now that it is same, now we don't need to do this. Oh, what? Why is it still 5? I don't get it. Jingle bell, jingle all the way. Oh, okay. Now we'll have to do ct1 plus plus, right? Shall be, but why does that make a difference? That does make a difference. So, just like an idiot, I'm just gonna submit this, even though I know this might be wrong, but I'm just gonna do it. Because it's problem B, guys. It has to be easy. If they'll make such a strong B, then who will solve it? No one. We did it. Oh, what a rank! 1969. I like that number. Okay, now the hard version. Ah, that's something. Okay, so as we know that this will obviously not work. Oh, what we can just do one modification, right? So what I'm thinking is that if we are getting like ct values as 2, 4, and 4 and 2 and 4, and we have the answer variable that the number of operations we have done. So, oh no, no we can't. This is tough. Um, so this is 2424, kind of like this. Or let's just take the first test case, and that would be like 4, 2, using our algorithm. So 4, 2, 2, and 2, right? So this will how it look like, and this would be 1, 0, 1, 0, right? This will always be alternative. This can either be 0, 1, 0, 1, but that doesn't matter, I guess. And since we are actually doing 3 operations here, and the size of one of these zeros, so earlier it was like 3, 2, 2, 3, right? So if we I don't know what, if we just make this to be a 4, and then we can just join all of these by removing this 2. Hmm. So it's like carrying over. 1, 2, 3, and combine this to form 6. And it will still take the answer as that. And now that's fucked up. So let's look at some test cases. This one, they say they can do in 3. Okay, so this is taking 0. 0 changes anyway. So 0 would be like um, um, the number of segments, or what we call CT1 dot size, right? And for this, we can do like CT1 dot size. Let's try -1. Of course, this is wrong, but what happened? My bad. Okay, it looks like we are wrong. Certainly. Uh, let's just do this. So if we remove one subsegment, like we just remove it completely, then the number of subsegments actually reduced by 2, right? So if we remove subsegment, then number reduces by 2 and not just 1. That is something. Just like in this one, we can remove what? We can remove these two and replace this with a 0. So replace all of this with 0 and this with 0. So what I can do is basically, uh, currently I'm just changing wherever there is a switch. I'm just changing this to be 0, 0. And like, we are not concerned with the string. We just want the minimum number of subsegments we can do. So there has to be a pattern, I think. So like if the end string looks like 1, 1, 0, 0, 1, 1, right? So what we could do was we changed this to this, right? But what we could have done was something else. So like uh, I might be wrong, but what I think I'm observing is that length of 2 is reducible. Like if we get string of length 2, then that is reducible. The reason being, and also a condition that we had to change one of its members plus, and we had to add a member to it from the end, right? So what I mean by this is that uh, let's say these are the subsegments 1, 2 and 3. So for making like 1 to be even, we took 1 from 2. So we took 1 from 2. So let's let's denote it like this. And now what happened was 2 became odd. So now we needed to add here, right? So every such string that required this thing and it has a length of 2, we can reduce it by actually removing the substring itself. But I'm not sure about this approach or like this condition, like length of 2, why length of 2 only, and what if there is like a reason. And another thing is that this is odd, that's why we are taking from it, and this was even, that's why it became odd later on. So everywhere if there is like odd even, you can say that we are actually increasing it. So yeah, I think so. Every case where this is odd even and the even guy is of length 2, we can reduce it. And also we also have to take care of that this should be odd, right? Because if this is even, then again this is like kind of odd summation of this and this. But I'm not sure. Like, what if this length is greater than 2? Let's say this is 4. And so the number of replacements we need to fix this is basically 1 here, right? So let's say this is 3, and this is 4, and this is, let's say, 5, right? So the number of fixes we need is 1 here, right? And now this is again 3, so now we need one more fix to fix it to be a 4. And what, wait a second, yeah, so this will be reduced by 1, and that would do it. So in this case it's not a good thing to do that, to remove 4, right? Because the number of operations would require be more. So I think my approach is correct, but I'm not sure. Um, what we can do is just try it out. I can just goes if it goes wrong, it goes wrong. I don't really care. Then I can maybe try C. Although I'm quite done with the contest, and instead of doing all of this shit, I just need my audio and stuff, right? Uh, does that look okay or not? I think that looks great. Hmm. And I just need to vector int ct2, let's say, and I just need to replace this with ct2, right? And ct1 is equals to 0 at the start. Now I'm gonna do something like for int I equals 0, I less than ct2 dot size, and I plus this, and if so I'm not sure about this thing. I am sure about that. If ct2 of I is equals to, right, then we can, or less than equal to 2. So that will be based on that condition, but I'm not sure. Because that is the only way we can minimize like the number of operations. And now the extra conditions, I don't know about them. What I can do is create a vector, another vector, ct3, and uh, 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 hmm. I is greater than 0 and I minus 1 ct of I minus 1 is odd, and if I is greater than I is less than n minus 1, and ct2 of I plus 1 is odd, because only in that case we'll be removing these, I guess I'm not sure. uh, then we can reduce our answer by, not answer, so current subsegments are subsegments is equals to ct2 dot size, or ct1 ct dot size, right? And um, say transaction minus or minus 6 2. Now that's a risk. I can test it on a lot of test cases to check if it is correct or not, but oh, it just failed. Ooh, it just failed on the trivial test cases also. Now what to do? And okay, so this should be equals to, but that's not it, of course. And this should be now this should work, right? At least for this test case, it should work. So for one, we won't have to do it because if we have changed it for the previous guy, uh, so like if this was odd and this was also odd with the length of 1, then we would have just made it vanished anyway, right? So we would have made it vanish. But if let's say this was even and this was odd with length 1, right? This was odd with length 1 and so we needed to fix this, so we would have taken something from here, and let's consider the two test cases that would happen here. So either this can be even or this can be odd as well, and if this is odd, then if this is odd, then if we take 1 from it, then this will become even and this will be like even, and we are sorted, so this won't be taken from ahead. And if this is the case, then even, and now that, how did the previous be past the pretest? This will fail, right? Because this is odd, and now you change something in this. Now this is also odd. How does this work? So a test case would be like 1 1, and then 0, and then 1 1. And if I do my algorithm, that won't work. Simply won't work. Oh, this would work. So if we would change, no, we won't change. This would be 0 0 and this one. Yeah, my algorithm won't even work, bro. The fuck is this? So what I literally did here, does that not make sense? I'm a little worried because um, this is not working as expected. Uh, one thing to note is that if there are three changes required and we have, let's say, how many subsegments there? We make a 1 here, 0 here, so 2 subsegments and then 3 and then 4. We have 4 subsegments. And in the last case we have 3 changes and we again have, no, we have 3 subsegments here. So what this means is that 4 subsegments here, dot 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 dot. So we made a change, let's say here, and we made a change here, and we made a change here. So in 4 subsegments we have no idea that if the change was could be reduced, like what I did over here, like condition like this could be reduced, right? So we are taking something from this, right? So we are adding and then taking here, adding and then taking here, 1 2 1 3. Of course we are adding here. So in 4 also uh, we can say that we can reduce it by 2. I'm not sure. So if it would have been, what I'm saying is that if it would have been 3 changes and 5 subsegments, then I won't know that these 3 changes are there. But in 4 I know that they are in like almost every subsegment. Plus also my algorithm just went wrong. That's painful. CT2, where is CT2? Oh, we would have, oh, by the time we are making CT2, we would have changed the string, right? So what we want is, this should be done before that should, right? Now let's see it. I want it. I got it. I want it. I want it. Oh, what the fuck? Bruh, 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 bruh. Oh, we have to make it 1. What the fuck? So if this is less than, then I plus 1 would actually be ct2 dot size minus 1. Then this should not break, according to me. And this is breaking. And that means I fucked up somewhere. And I don't know where. Also, we got to know that our algorithm is wrong. But it somehow passes B. Although pretest might be deceiving and would lead to a wrong answer later on. Okay, GG's. I guess that's it for me. Or let's just say try for another 5 minutes. What I don't get is that why is this not running? Oh, wait a second. Our algorithm is correct. The reason being, uh, this case would never occur because the n is even, right? So n is even, so that means this case will never occur. So there will always be like a one error. If not, then this one. And the problem is that why is this not working? Mhm. Let's print out ct2 of I. So we are debugging here. Nice. And why is this happening? I have no idea. No fucking idea. Oh, for some test cases. I don't know what just happened here. But it is literally greater than 0, bro. I have no fucking idea. What? Again a segmentation fault? Have they gone crazy? And now it works. How? Just tell me how. Hmm. Hee hee. Let's just see that. So we have 3, 2, 2 here. So 3, then 2, then 2. Oh, we forgot the last ones. Oh, I see, I see, I see. So we forgot the last ones. My bad, my bad. CT2 dot pushback CT1, and that is correct. Okay, still we don't get the correct answer here. Okay, 3223. Right, we have a 2 here. Oh, so the next guy is even according to him. So if he does remove this, then odd plus even plus anyone would still be odd. So it is not removing this. And oh, but we are fixing it. Oh shit. Ah, that's fucked up. We're fixing it on the way. Uh, and those numbers are changing. So, what I need to do is, I need to keep this loop, right? Um, oh, that's hard. That's hard. So inside of this loop, I have fixed this 3 to take up 4. So this has become 1. So now I just need to add this condition inside of this is. Uh, how will I do that? And also, how will I keep an index of ct dot size? I'm trying to say is if ct1 is equal to 0 and not 0 is equals 2, and so for the previous one we'll take the count of ct1. uh and for the next one we're going to take count of ct2. And I hope by this method I'm not changing any subsegment count, but I am actually changing the subsegment count. Reason being the same case as this, right? So if I am applying this algorithm to this, so this is actually changing 0 1 0 to 0 0 0 or something. This is actually removing this subsegment, my algorithm, and that means this might not work here. So now what do we do? What do we do? What we can say is that if we encounter if CT1, we have to do it right here. So if CT1 was even or odd, then we can say that our previous was 1. 1, and we can initialize previous with -1 for starters, and since our previous was 1, that means our previous element was odd, and our current element is 2, right? We can say that previous is equals to 2. So this is like a special condition, or we can actually initialize it to any other number also. Special number. And we can just say that if previous is equals to and current element is equals oh wait, and current element is odd, that's why we can say that if previous equals to, then we can do what? This should be done after this. previous equals 2, then we can remove the previous one, and basically subsegments minus minus. So or we can say int minus equals to 0, minus plus equals to, and we are displaying, you can just say ct dot size minus minus. Fuck, why is this not working? Damn. The current element has a length of 2. Oh, all of this should be done when we push back, right? We actually push back. But we will only push back even values. And then let's move to the fuck am I doing? I have no idea. So what I thought was, since I'm removing 1 from this should be 1, right? But the truth is, this is also getting an even. So essentially, this is never possible. Oh, I think that's how we can do it. If there is an element of length 1, right? If there is an element of length 1, that means if it was of length 2 earlier, and but how can we say that it was of 2 earlier? So it could be something like this, where this is 4 and there is a 1, and there is something like so this gonna be this. Mhm. And this 3 can be further divided into 2 and 1, let's say. Oh, so it doesn't matter if the next one is an odd or an even. If we get a 1, we will remove that. Are you getting me? So all of this logic goes to trash. Or I can just take my previous submission, which was this, and do something like, oh, it was not this shit. Shall we do it? Like, shall we create this string, or we can just increase or minus? No? And then we can just say minus equals 0. Copy our string. So we don't. Wait, what the fuck? Okay. I declared minus equals to 0, right? What the fuck is this? And that's all that. So okay, what happened here is that let's see out minus. So probably what happened is minus was much larger. So but why would it go? It's not. Oh, it is unsigned int. That is something. How do I convert this to int? Although what happened here is that when we did 1 1 1 to 1, this 0 actually became a single entity. We remove this. Since we remove this, we shouldn't have removed this, or should have. So if we remove this, we can still achieve that. Right? So if we remove this, so what we can say is that st of I is equals to st of I plus 1, and we can say answer plus plus, and we can also set flag to 1, and we can also say that ct1 plus plus. What the fuck am I doing? What I can do is ct2 dot size minus 1. So this will give me the last element that was added, and I want to increase 1 in that. No, not 1. But okay, how do I remove this? Can I add a 0 inside the vector? Inside that vector? Or what we can do is, if we have encountered as one letter string, then you won't consider the next one of one letter, right? Just like in this case, this was a one letter string, so we remove this and we don't consider the next one, but that's what not now. So we can move this and we can change this. But what if in this scenario? So this has a 1 at the start, so we'll ignore that. But as per our algorithm, we'll place a 1 here. And now there is a 0 here, so we'll remove this 0. And we'll remove this 0. But we don't have to do a minus minus for this one. I mean, this is working for this one, but this won't work. This just won't work. I could remove this one, set a 0 here, and then I see two ones, but I change this to a 0, and then again 1, then so in this case we can actually change it the string to either full of zeros or full of ones. But the problem I have is that you guys can see the problem. Oh, this might work. So I'm just gonna ignore the end ones, right? And this is what I am doing. Why is the compilation time getting this? So this might just work. Just some of this. So this is not the approach. Fuck. Okay. This has a permutation p of length n. Call that permutation is a sequence. She wants to know how many different indices tuples in this permutation satisfy the following two inequalities. So PA is less than PC. So at position A and position C, the element at position C is greater, and at position B is greater than position D. Now that two tuples this and this are considered to be different if A1 is not equal to this. So if any one of these is not equal. Okay. N is 5000. Can I do a 4 times nested loop? Can I? I'm literally thinking of doing it. Okay, let's see the number of summations for this. If the number of summations are large, then this could probably be, no, they are not. Sure. But just to tell you guys the brute force approach, what we could do is we could go for, and since A is less than B less than C less than D, it would actually be much shorter than we expected. So it would look like int I is equals to 0, n I plus plus. But since like 1, so we'll go from 1 and we consider this 0 to n minus 1, right? So if n minus 1 is D, these can be n minus 2, n minus 3 and n minus 4. Right? So A can be at most n minus 4, so that means less than n minus 3 for j is equals to 0, or you can just take A, right? A. B equals to A plus 1, B less than n minus 2, B plus plus, for int C equals to B plus 1, C less than n minus 2, n minus 1, C plus plus, for int D is equals to C plus 1, D less than n, D plus plus. If P of the answer would be int answer equals to 0. Long answer is equal to 0. We are just gonna copy this template that we had. For each test case. So we can remove this and we can store. I hope that is correct. So we don't need a map. Don't need any of this shit. Definitely this is not the way to do it, because this will get a TLE for sure. But I just wanted to show you guys that. Okay, I'll just try. Let's just see if we can get the answer. Forgot to output the answer. Yeah. So I should not submit this, but I'm feeling great. Okay, let's do some optimization. So 1 to n, that means, what does that mean? That means if there is a number 1, then there cannot be a number that is smaller than this. So if p of a is, or p of c is 1, right, then we can skip checking, but that would not make a difference. This is a permutation question. So we can choose a to be n different things, or n minus 1 different things, right? We cannot have a to be n, because then there wouldn't be any c that is less than this. Multiply it with number of values c can take would depend on this number. So now that's fucked up. And b and c are not same, so a shall be between this, so that b at least has one choice to go. this guy has n minus a choices, or how do I say? Sum of n overall test cases does not exceed 5,000. What does that mean? Is it helpful for us? Okay, so this would be n minus 1 because they're also in ascending order. So if b is larger, then it has to be n minus 2. So b can be 1, 2, 3, 4, and 5. Oh, I'm thinking of something shitty. This is not the question. And A, B, C, D, and are indices. And if we fix A to be 1, then we cannot make B to be anything else. So B can be either of these and C can be. Then we can't just make A, B, C, and D. So A can either be this, or this, or this. And since we have to choose a smaller number than C, it's like it's like what is it like? It's like choose this number, then choose this number, choose this number, choose this number. I can't think of any better way than a 4 nested loops. Because let's say if we fix these 3, then we're gonna traverse over all of this shit and just see wherever the condition satisfies, and that is exactly what I'm doing. B is greater than D, so basically we just have to find number that is smaller than this inside this range. Who do we fix first so that we can optimize? What should we fix? Nothing makes sense. Let's see the time complexity. 5,000 into 5,000 into 5,000. So 5 into 10 squared. This is getting multiplied 4 times, so 10 squared 12 for each test case. That's pretty large. And that requires to do it in 1.5 seconds, the whole thing. And this multiplied by another. So that is like just by 50. So 10 raised to power 15 instructions. So if we take that, a computer does how many instructions per second? How many instructions per second? Instructions per second. 2, 4, 6. So if we can do 2 into 10 power 8 in 1 second, then in 1.5 seconds we can do 3 into 10 power 8. 10. So this is DLE for sure. But it's not reversing the whole thing, right? So it actually can be a much smaller number. We can say n minus 4 cube. But let's just 5 is here, 3 is somewhat here, 3, and then 6 is above here, 6, and then 1 is here. One is here, 4 is here, 4 is here, 5, 3, 6, 1, was 5, 5, 3, 6, 1, 4, and 2. All of this shit, and we could only find. And there are only 3 things that says. Isn't it weird? And there are 26, 28 in this. When a sorted array, there are none. That's quite interesting. So this suggests a sorted array, but this suggests the opposite of that. So it's like what we can do is we can see a part of it that is sorted, like 1, 2 is sorted with themselves, or is it bad to look at like that? Like that. 1 and 2 are sorted, 3 and 4 are sorted, 6 and 1 are anti-sorted. अगलावा मजबूरी में अचानक सूरी में शहर बने हम तेरे पीछाना पूरी में and 3 and 1 are also anti-sorted. 3 and 1 are anti-sorted, 5 and 6 are sorted. But why only these? Oh, okay. Okay, it's like we jump from this element to this element. Find an element inside of this that is sorted with some element on, on this side. So we pick two sorted elements, or and then we pick some number between them. But that is what we are doing in brute force, right? Isn't it? Isn't that what we do? So find every pair that is sorted and keep them in a what? In a what? How do I keep them? So I can basically go over every pair because I think our time complexity allows that at least. I plus 1 and if p of I is less than p of j, then we can store it. And now we have to pick any number between I and j, or what we can do is we can do the same for anti-sorted. That means, but how will we make sense? So now we have some pairs. Let's say the pairs are like 1 comma 2, let's say 1 comma 3, and we can also make sure that there is at least a difference of not just 1, just maybe 2, right? Because there's no point if there are not 2, because we need an element between them and one outside them. I don't know if I'm making sense or not. So let's say this is the sorted list. So 1 comma 3 are sorted, and let's say 2 comma 7 are sorted, and so on something. And anti-sorted, let's say this is a list like 2 and 5. So we know that 1 is smaller than this and 3 is smaller than this, so but greater than this. Can we do something? So if we do this, that would be of the order of n square, right? I'm just gonna go with this approach. So vector, even though I don't know, so sorted pair, and what am I gonna store here? I and j, right? Here also. And now the condition. The condition is basically if it dot first, the first guy, एक सेकेंड
अच्छा
So if IT dot first is so every guy in the sorted list is basically our A, right? And we could actually say that this is less than n minus 3. Can be. Of course you can, right? But shall we? Should we? And C is less than n minus 1. And there is no restriction on D. And but for B we can only have n minus 2, right? And now that we have that, so just reducing the time complexity for that. I don't know if that would make a difference or not, but let's see. Yeah, so A, we already know that what the fuck shit. Oh no. Let's try this. Now we just have to make sure that we have found AC and BD, and we just have to make sure that A is less than B. So for that, A is less than B. IT2 dot first, right? And IT uh, A is less than B. A is less than C is sorted by using this. So A is less than D, right? So we have to also make sure that. But that would be obviously the case because uh, uh, B is less than D. Then it is obviously true. So we don't need to do that. Now what? Is less than B. A is less than B. And we just have to make sure that C is B is less than C. Is this what we have to do? So B is less than C logic would look like IT2 dot first is less than IT2, IT1, IT dot second. So B and C are compared, and do we need to compare C and D also? Of course we need to, right? I guess we need to. So IT dot second is less than IT2 dot second. Right, that would do for D. And if that's true, then we do answer phosphorus. But still, this loop would go over every loop, and since it is doing an increment just by 1, how is this reducing the complexity? It is not. Or is it? Can we store these in sorted order? But aren't we gonna do that anyway because we are just pushing back? And even if these are in sorted order, what does that mean? Does that mean like I don't have to check like, so if 1 comma 3 does not satisfy with this, but it does for this one, so it can be like 1 comma something. I don't want to do that. Okay, let's just see that if I can get the answer through this. Let's see if I can get the answer to this. Did it just work? But this works. Contest is over. Come on, let me practice. Oh no, GG's.